Two identical bowls, A and B, made of plastic and metal respectively, were each filled with 200 ml hot water at 90 degrees Celsius. So these are all clues that this question is about heat. All right, and because there's plastic and metal, it's about heat conductors as well. All right, and we were placed in the science laboratory and were left unattended for an hour. So which of the following line graphs best represent the change in the temperature of water in bowls A and B over time? So uh, before we do this question, let's look at the concepts needed to understand. First of all, we know about heat flow. This is just a revision. You should know this by heart already. If you don't, please pause the video at this slide and read everything that there is on this slide and make sure you understand fully what is being written. Okay? Commit it to memory because you'll be using this for the next few years, all the way to PSLE and even in secondary school. So please, make it an effort to read this slide and understand it completely. Now we know that heat always flows from a hotter to colder place or object until, and this heat continues until the two places or the two objects reach the same temperature. Alright, we know that when matter becomes hotter, they gain heat, and when they lose heat, it becomes colder. Now, we know that their materials can be divided into two groups: heat conductors or good heat conductors. All right, good heat conductors are materials that allow heat to flow through them very easily. All right, example of good heat conductors would be metal. Metal is a very good heat conductor, and that's why our pots and pans, kettles are all made up of metal, because we would really like the the heat from the fire to flow through the metal easily so that it can be transferred to the water that we want to boil or to the food that we want to cook. We also know that there are materials that are not good conductors of heat, and they're called poor conductors of heat. Now, I know at this point, some of you will say, oh, they are insulators of heat, all right? Well, actually, try not to use the word insulators. Instead, a better phrase for it would be good conductors of heat and poor conductors of heat. So, what you would think of as an insulator, instead of using the word insulator, try to use the word poor conductors of heat. Okay, so there are poor conductors of heat and good conductors of heat. Now, examples of poor conductors of heat would include wood, plastic, and rubber. All right. Okay, so knowing these two concepts about heat flow and heat conductors, let's look at the question. Two identical bowls. Now, if you look at the stem of the question, the main question, which are the following line graphs. I'm not going to show you the line graphs as it appears in the MCQ, but instead I'm going to show you what a line graph will look like. Okay, we have a line graph. In any graph, there must be two axes at your level at least. Okay, there's a time, which is the horizontal line, and the vertical is the temperature. Okay, so over time, can you see the word over time here means time? As the time pass by, okay, from smaller, this junction here is 0. All right, when you start the experiment, it flows all the way to when the experiment ends. All right, so both water are placed in what do you call that, in a bowl, but one is made of plastic and the other is made up of metal. We know metal is a good conductor of heat. What this means is that it allows heat to travel from inside the bowl, from the hot water, to outside the bowl into the air. So the water here can actually be transferred. All right, the heat actually can actually escape. All right, from the heat here can actually escape from inside the bowl, okay, to outside the bowl to the air, because it's a good conductor of heat. Okay, so you can see that the water, because it's a good conductor of heat, the water will get colder, will get cooler much faster. All right, so it can travel from inside the bowl to outside the bowl. Okay, the heat can travel from inside the hot water, from the hot water inside the bowl to outside air on the outer side of the bowl. Okay, whereas for plastic, it's not such a good conductor of heat. Therefore, the heat will still flow, but it is not as good because some of it will be trapped or will be prevented. All right. So you can see that this is the idea of the question. The question want to see whether you know a metal bowl is a good conductor and a plastic bowl is a poor conductor of heat. Now, if the metal bowl is a good conductor of heat, all right, if the metal bowl is a good conductor of heat, then what happens is that, let's say this is 90 degrees, what happens is that as more and more heat escapes the bowl, all right, you will see that the temperature will be decreasing, okay? Because as it starts at 90, it will go down all the way to room temperature. Okay, and this can be represented by a line like this. Then how about the line graph that represents the heat in the plastic bowl? Well, again, it's gonna start at 90. Why will it start at 90? Because the question says so, that both of it will be is 90 degrees. So let's use a different color here. Okay, so at 90 degrees, sorry, at 90 degrees Celsius, okay, 90 degrees Celsius, which is the temperature, all right, it will travel uh, and become cooler, become colder as heat escape, but it will cool down at a slower rate. Why it's cool down at a slower rate? Because the heat that escapes it, right, will be traveling at a slower rate because the plastic is not a good conductor of heat. Whereas for the metal bowl, the heat will be escaping at a very higher rate, at a faster rate, because at a higher rate because metal is a good conductor of heat. One more time, if I can just repeat that, okay, for the metal bowl, the heat will be escaping easily because metal is a good conductor of heat, and because it's a good conductor of heat, it allows the heat from inside the bowl to travel out of it and escape it. And when more heat escape, the temperature here will be lower much faster. Whereas for the plastic bowl is a poor conductor of heat. Heat will still escape, but at a slower rate, at a lower rate. And because of that, the thermometer will be reading a slower decrease in temperature. All right, and what I've just said can be represented by this line graph here. All right, this line here, the black line, shows a faster decrease in temperature, and the green line here shows a lower decrease in temperature over time, because the metal bowl here is a good conductor of heat and the plastic bowl here is a poorer conductor of heat. Okay, so I hope you have understood what I've just explained. Again, the usual reminders. This reminder will appear at almost every video and you will see more of it. Okay, do pay attention to the reminders. All right, repeat and replay the video if you didn't understand. Take down notes so that you're telling yourself, you're telling your mind, your brain that these are important facts that you must remember. Okay, if you can draw a mind map, do so. Send me questions over email or in class. Okay, write your comments below if you are using your parents account and you have an account. If you're using your parents account, you can just write your comments below. It's always good to hear feedback. If you spot any mistakes in my video, send me an email and I will try to correct it. All right. Only human, not perfect. I'm sure I've made tons of mistakes, grammatical or otherwise. Okay. And then effective communicator challenge. If you can make your own video and show it to me, it'll be great. Okay. So with that, thank you very much.